All right, guys, this one is going to be really brief because it really should have been added to the end of protein synthesis. So we're going to talk about mutations in this note set. Um, a mutation is a change in DNA, right, which leads to a change in protein or not. Um, there are two types. There are two main types of mutations. A point or substitution mutation is one where one base is replaced with a different base, right? A frame shift is the second type that we're going to talk about. This is where a base is inserted or deleted, so the entire sequence is changed from that point on. It changes the frame um, of the frame that the tRNA reads. Okay. All right, so there are different types of point mutations. First one we're going to talk about is a silent mutation. This is when there's a change in DNA that does not change the amino acid. So this doesn't lead to a change in the organism. So for example, in this case, if you had ATGGAA and it changed to GAG, but when that happened, you still got the amino acid glucine, then that's a silent mutation. So it's a change in the DNA, which in this case doesn't lead to a change in the protein. The next type is a missense, right? This is when one amino acid changes that is important to the function of the protein. And this is what happens in sickle cell, guys. The whole disorder of sickle cell anemia is caused because one single base changes, and it changes an amino acid, and it changes the entire chemistry of the protein. All right. Um, so uh, this would be a big deal. Let's say we talked about hydrophobic and hydrophilic. Let's say this one was hydrophobic and you changed it to something that was hydrophilic. It would completely change how that protein is formed. Okay. All right, then we have nonsense. A nonsense is when the codon for an amino acid is changed to a stop codon, so you get a protein that is short and non-functional. I like to think of it as you started getting dressed and you stopped before you were finished. Now you're looking a hot mess. All right, and this is what happens with cystic fibrosis. So with cystic fibrosis, you have a mutation that pretty much changes a codon to a stop codon. And you know what happens when you get to a stop codon? The proton gets pro, pro protein chain gets stopped. And so with cystic fibrosis, this happens and you get to create the first 493 amino acids. But for normal function, you need 1,480. You could see how that's a problem. Think of it if that were money. Like if you were supposed to get $1,480 and you only got 493, right? And here is all this in a nice little Google picture. All right, so this is when you have no mutation. This is a silent mutation, so something changes, but it doesn't change the amino acid. All right, here something changes and it changes the amino acid to a stop codon. And then missense is when it just changes it to something else that doesn't make as much sense. All right, all right. So the next type we talked about was the frame shift mutation, and there are two types of those. So it could be an insertion where one or more bases are inserted and it changes the read-in frame, right? So here we are. We're going on, and whoops, where did this C come from? Right? And this is what happens in this case of Huntington's disease. It is caused by an insertion of base or bases. A deletion is literally just the opposite. It occurs when one or more bases are deleted. Some forms of muscular dystrophy are caused by this. So here's the original sequence, and you're going, you're going, you're going. Whoops, we lost this T that was right here. So now the whole frame shifts. So instead of having TAA, CTG, you're going to have TAA, TAA, CGC, and so on. Then you're going to have AGG, and then you're going to find out that, hey, this doesn't have, that's an extra one there. Okay? So that's a deletion. Here's a little sentence analogy. So this is the normal sequence of the sentence. The red cat ate the fat rat. Okay? And in a silent mutation, something would happen, but you would never know, right? So it would still be the red cat ate the fat rat, right? Um, in a missense, right? A letter gets changed in a way that now the sentence doesn't make sense, right? The red hat ate the fat rat. Okay, that makes no sense, right? And then in a nonsense, something gets happened and the sentence get cut short. The red cat, I should say cat because that's not where the change is. The red cat ate the, and the sentence is done. Okay, so I'm gonna fix that, but this should be cat. Hope I didn't make that mistake again. No, I didn't. Okay, great. In an insertion, you put in something else. So here we put in this B, and it completely changes everything, as you can see. Now we have the reb, this can't even say that, tat, effa, right? And then in a deletion, you have we take out that D, we've lost this D, so now we have REC, ATA, TE, and so on and so on and so on. All right? So that's the analogy if it were a sentence. And then you guys are going to actually do some practice in class. All right, that's that. Told you it was going to be short.